Okay, so in chapter 4, section 3, in polynomial division, we have two types of division. Long division is one we grew up with pretty much in elementary school. Something like 27 divided by 3 can be put in this form. 3 goes into 27 9 times. 9 times 3 is 27. Turn around and subtract it. This is your remainder. This is your quotient. This is your dividend. And this is your polynomial. So your polynomial can break down into your denominator times the quotient plus whatever remainder you have. So that's how it breaks into pieces. This is R of X. The reason I'm showing you this because later on in the homework assignments, is going to ask you, okay, what is D of X? What is Q of X? What is R of X given P of X? Okay, so that's long division. And then we have a faster way called synthetic division. Synthetic division would look like this. You notice how the dividing is backwards on these things. They do this so you know which method is being used when you just look at it. In synthetic divisions, you only use the integers. There are no variables. Right, so what is the purpose of polynomial division? The purpose of polynomial division is to factor a polynomial into its linear binomial factors. In other words, it takes a big number and makes it down to smaller ones. For example, we see from our example here, what this tells us is 27 is made up of 3 times 9. So we start off with this, that's our numerator, and we broke it down into 2 smaller components, and we keep on going from there. So that's pretty much the gist of it. And here's an important factor. If the remainder, R of X, if the remainder is equal to 0, then your divisor, your bottom number, is a factor of your polynomial, as is your Q of X, your quotient. So here's our P of X, here's D of X, here's our Q of X, and our remainder was 0. So we know that our P of X breaks down into D of X times Q of X, which are, both of these are factors. And I apologize because it does make it sound more complicated, but it's a lot easier than that. Especially if it equals 0, if the remainder is equal to 0, then you know you have a factor. Let's look at some of these examples. This is section 4, chapter 4, section 3. This is question 1. We have this polynomial. We have that polynomial. It's asking us, is x plus 6 a factor? So how do we know if x plus 6 is a factor? If x plus 6 is a factor of this big polynomial, the remainder would equal what? 0. When we do division. So let's practice doing long and I'll show you synthetic division also while we're at it. So here's our denominator. X plus 6, does it go into x to the 4th minus 3x cubed plus x squared plus 5x plus 585. So that's if it's a factor, does it divide into that number? That's what we're looking for. When I ask you, is it a factor? Does it divide into it evenly with no remainder? Now, the steps here only look at the leading terms. So here's the leading term of the denominator. Here's your polynomial. What times x gives us x to the 4th? X to the 3rd. Yeah, because here's 1x. I need to get 4, so I have to put 3 more in there. So now, once you find that number, now you multiply it to both of those. X cubed times x gives us 4x's. X times positive x cubed times positive 6 gives us positive 6x cubed. Remember the example I gave earlier where that 3 goes in 27? Now, after I did this, after I found 3 goes into 27 9 times, what do I do next? I took this number times that. So 9 times 3 is 27. That's what I just did. Now I subtract them. I changed the sign of the number I put down there. I changed the sign of it. So I do the same thing here. I change the sign of these numbers. Now I add them. The leading term should always be eliminated when you add them. So x to the 4th minus x to the 4th, that disappears. Negative 3x cubed, negative 6x cubed is negative 9x cubed. Bring down everything else. Repeat the process. Look at the leading terms. What times x gives us negative 9x cubed? Yeah, we have 1x there, we need 3, so we need 2 more. You also notice on the answers, the numerator here, the powers are going to decrease. So negative 9x squared times x is negative 9x cubed. Negative 9x squared times positive 6. So I've multiplied both of these guys. So negative 9 times positive 6 is negative 54x squared. Now I have to change these signs. That one changes to a plus, and that one changes to a plus. Change the signs, now add. Negative 9x cubed plus 9x cubed, they cancel. 1x squared plus 54x squared is 55x squared. And bring down everything else. Repeat the process. Look at the leading terms. What times x gives us 55x squared? So remember, it's a 1 here. So 1 times what is 55? It's a positive 55. We have to make sure we put the signs there. X times what gives us x squared? X times x. Remember, look at the exponents. 3, 2, 1. The next one's going to have no exponent, no x's. So now we'll multiply. 55x times x is 55x squared. 55x times 6. So 55 times 6, they're both positive. It's 330x. Change the signs. This one's positive, I change it to negative. This one's positive, I change it to negative. Now I add. 55 minus 55, they cancel. 5 minus 330, since 330 is bigger, the answer should be negative. 330 minus 5 is 325x. And bring down what's left. Repeat the process. Look at the leading terms. What times x gives us negative 325x? Negative 325. So negative 325 times x is negative 325x. Negative 325 times 6 is negative 1956. Change the signs and add. So negative and positive, they cancel. Here I have positive 956 plus 586. It has to be positive, it can't be negative. So this is 11, 14, 6. No, it's 25. 2541. There's your remainder. So is x plus 6 a factor? Nope. X plus 6 is not a factor. So basically, putting it in this way, remember, this is your little d of x. So your little d of x is x plus 6. The q of x is the top number, is a quotient, x cubed minus 9x squared plus 55x minus 325 plus the remainder. That's how it breaks down. All right, let's try another one. Do you see what the most obvious problem of this method could be? No, you can't do anything. Well, yeah, because since it's no factor, then actually we know, all we know is x plus 6 is not a factor. We try another number, but we'll get to that in the next section. Because yeah, we have to break it down to all possible combinations. All right, so that was number 1. Let's look at number 2. Question 2. Given g of x equals x cubed plus 7x squared plus 2x minus 40, is x plus 5 a factor?
So we'll use this in the next chapter to check our answer.
Well, we have faster ways, yeah. Okay, so we test. So we take this is your d of x, x plus 5, and see if it fits into your polynomial.
Oh, on these long division, does it have to have? Are we going to put a space?
Yes, if something's missing, like it doesn't have an x, you have to put a 0 there. You have to fill every column up.
I knew we had to do that for synthetic.
The question was, what if we had a number that they didn't have that? It just had x cubed plus 7x squared minus 40. Since, look at the exponents, 3, 2, 1, 0. We're missing a 1x, so we'd have to put a 0 here, 0x, to hold that space. That way it holds everything down the line. So let's begin. What times x gives me x cubed? X squared. Take x squared, multiply it by both of these. So x squared times x is x cubed. X squared times 5 is positive 5x squared. Change the signs. Now add. X cubed minus x cubed, they cancel. Remember, the leading terms always have to eliminate. 7 minus 5 is 2x squared. Bring down everything else. Repeat the process. Look at leading terms only. What times x gives me 2x squared? I need a 2. I need one more x. This is 2 there. There's 1 there. So I need one more x. And again, look at the answers. It's going to be decreasing. 2x times x is 2x squared. 2x times 5 is positive 10x. Change the signs and add. 2x squared minus 2x cancels. Leading terms always have to be gone. 2 minus 10x. Since 10 is bigger, it's negative. 10 minus 2 is 8. And bring down everything else. Repeat the process. Look at the leading terms only. What times x gives me negative 8x? I have an x already, so I'm missing a negative 8. So it's a negative 8. Multiply that. So negative 8 times x is negative 8x. Negative 8 times 5 is negative 40. Change the signs. Because remember, the leading term has to disappear. So negative 8 plus 8, they cancel. Negative 40 plus 40 is 0. That's what we're hoping for. So that tells us that x plus 5 is a factor. It gives us two factors, actually. We know that x plus 5, because the remainder is 0, it also says that x squared plus 2x minus 8 is also a factor. Remember, this is the little d of x. This is your q of x. Since the remainder is 0, both of these have to be factors of this big long one. So our answer would look, if you're asked to put it in this format. So we know p of x is x cubed plus 7x squared plus 2x minus 40. That's your original. Equals the little d of x. X plus 5 times your q of x, x squared plus 2x minus 8 plus your remainder, which is 0. So it just really equals that. All right, so let's suppose now the next two problems are going to ask us to put it into this format. I'll just give you a heads up on it. All right, question number 3. Put it in this form. Given p of x is equal to x cubed minus 512, and d of x is equal to x plus 8. So what you have to do, you have to find the q of x and the r of x. We're looking for q of x and the r of x. So we can put it in this form. So given p of x and little d of x, we put it in this form. Whatever's on top is going to be our q of x. Whatever's down here will be our r of x. Let's do this with long division. X plus 8 goes into x cubed plus 0x squared plus 0x minus 512. Again, we have to put those zeros there. It starts with the highest exponent is x cubed, but it goes down to the constant. We have to put all those positions. Repeat the process we did earlier. What times x gives us x cubed? We need 2 more x's. So x squared times x gives us x cubed. X squared times 8 gives us 8x squared. See, if you didn't put those zeros there, what would you put the 8x squared? get really crumpled up. Change the signs and add. X cubes cancel. 0 minus 8x squared is negative 8x squared. Bring down everything else. Repeat the process. Look at the leading terms. What times x gives us negative 8x squared? A negative 8. We need one more x. So negative 8x times x is negative 8x squared. Negative 8 times 8 is negative 64x. 8 times 8 is 64. Change the signs and add. The negative 8x is cancel. 0 plus 64x is 64x. And bring down what's left. Look at leading terms. What times x gives me 64x? A positive 64. 64 times x is 64x. 64 times 8 is 512. Change the signs.
It's looking promising until we change the sign.
Okay.
Take out the zeros when we write out the p of x afterward.
Right. Hold it. Let's make sure, because there's a lot of negatives and everything. Let's just go back to this again. So x squared is x cubed plus 8x. So let's change it to minus. Negative x squared, 8x, negative 512. No, negative 64, I mean. Change the sign so it's positive 64. Positive 64 times x. Yep. So the p of x of this one is x cubed minus 512. The little d of x is x plus 8. The q of x is what's on top. X squared minus 8x plus 64. And the remainder is the last number using this template. If this was a negative, because this number here is actually the difference of two cubes. Remember, we talked about that earlier, which equals a minus b times a squared plus ab plus b squared. So If this was negative, it would have worked. But since it's positive, it made the first one positive, a plus b, and you can't go any further there. So that's the reason we had a remainder. But it is what it is. Let's do that again. So these are your answers that you have to enter in the computer. Let's look at number 4. Let's do that again. P of x is equal to x to the 4th minus 12x squared minus 64. And little d of x is x plus 4. It wants us to put it into this form. So we have to find Q and R. And here's the template that we're going to put it into. So we have x plus 4 goes on to x to the 4th. Remember, there's 4, 3. We're missing a 3, so it's a 0 x cubed minus 12x squared. We're missing an x and a minus 64. Look at leading terms. X times what is x to the 4th? We're missing 3 more x's. So it's x cubed. X cubed times x is x to the 4th. X cubed times 4 is 4x cubed. Change the signs and add. So negative 4x cubed. And bring down everything else. Repeat the process. Look at leading terms. What times x gives me negative 4x cubed? Negative 4 times 1 is that. I'm missing 2 more x's, so it's x squared. Yeah, because if this was x cubed, the next one has to be x squared. The next one has to be x, then the last one has to be a constant. Negative 4 times 1 is negative 4. X squared times x is x cubed. Negative 4 times 4 is negative 16 times x squared. Change the signs and add. 16 minus, since 16 is bigger, the answer would be positive. 16 minus 12 is 4 x squared, and bring down everything else. Look at the leading terms. What times x gives me 4x squared? A positive 4, and missing 1 more x. 4 times 1 is 4. X times x is x squared. 4x times 4 is 16x. Change the signs and add. Negative 16 plus 0 is negative 16x. Bring down what's left. Look at the leading terms. What times 1x gives me negative 16x? Just I'm missing a negative 16. Negative 16 times x is negative 16x. Negative 16 times 4 is a positive times negative is a negative. 4 times 16 is 64. Change the signs and add. Those negative 64 0 0. So we know x plus 4 is a factor. So our p of x is what's under that bridge thingy. X plus 4 minus 12x squared minus 64. Little d of x was x plus 4. So the quotient, that's the number on top. That's the answer part. X cubed minus 4x squared plus 4x minus 16. This is the q of x. This is little d of x. This is p of x. This is r of x. Much easier. So that, unfortunately, is a long way of doing it, but we have to show you this because the next method, the synthetic method, only works on certain cases. Synthetic division only works when the denominator is of the form x plus or minus a. No coefficient, no exponent, ooh. I don't know why it's always doing that. I'm sorry, everybody.
That's the tip of your pen sticking up higher than the paper. It's trying to
That's why I have the autofocus. Turn you off. Oh well. Okay, so let's look at this. Let's look at one of the ones we did already. We'll do the first one. Let's do the second one. Let's look at this process using the one we did already. The question number 2, we had this. X cubed plus 7x squared plus 2x minus 40 is asking, is x plus 5 a factor? Remember, this is your d of x. This is your p of x. First step, solve d of x equals 0 for x. So in our case, we have x plus 5 equals 0, x equals negative 5. This is what's going to, this is our new d of x. In synthetic division, instead of, remember, long division, we had this form where the top is q of x and the remainder is r of x. Now, this is what it's going to look like. This is long division. This is synthetic division. You might ask, besides the dividing line, what's the difference? You notice there are no variables here. It's just numbers. So for our d, we just use negative 5. And inside here, only the coefficients of x. What's the coefficient of x cubed? 1. What's the coefficient of x squared? 7. The coefficient of x is 2, and the constant is negative 40. Okay, these you don't have to write all the time, but I'm showing you, since the highest exponent is x cubed, we have to have a column designated for everything from the highest exponent down to the constant. So if I was missing an x, I have to put a 0 here to keep that line open. Now, the first step, once you get this written out, bring down the first term, the leading term. Only thing left now is a process of multiplication, addition, multiplication, addition. Take this number, multiply it by what's down here, and put it there. Whoa. So -1 times 5 is -5. Now add. 7 minus 5 is 2. Repeat the process. -5 times 2 equals -10. Now add. -10 plus 2 is -8. And take this number, -5, negative times -8. Negative is a positive. 5 times 8 is 40. And add. This is your remainder. This is your Q of X. That's your Q of X. The first number here is a constant. So it's -8. This next one here is an X, and then you build up from there. So the answer is x squared plus 2x minus 8. Good. Your answer will always start off with 1 less than the degree, the highest exponent. It'll always start off that way. So whatever you have down here, x squared, x constant. And if you look at what we just had earlier, this is the same answer we had when we did question 2 earlier. Here's what we did earlier. X squared plus 2x minus 8 with the remainder 0. X squared plus 2x minus 8 with the remainder 0. Where's the remainder 0? Which way is faster? I'll show you again. Here's question 5. Let's do another one. It says, given x cubed minus 2x squared minus 11, divide it by x plus 2 using synthetic division. Remember, this is your P of X, and this is your little d of X. Your first step is always take your little d of X and do what with it? Set it equal to 0. Remember, it's always going to be the opposite what's in there already. So the answer is going to be x equals -2. So there's that number goes out there. Now, inside this synthetic division radicand, the symbol, we just put the coefficients. Start with x cubed. What's its coefficient? 1. Next is x squared, -2. What's x? There is no x, so we put a 0. And then the constant, which is -11. Remember, the signs have to stay in there. You notice how little room I need for this? You don't need much room at all. In long division, you needed a whole page. All right, bring down the first term, multiply and add. -2 times 1 equals -2. Add. -2 minus 2 is -4. Multiply. -2 times -4 is a positive. 2 times 4 is 8. 8 plus 0 is 8. -2 times 8 gives us -16. Add those, we get -27. Remember, this is your Q, and this is your remainder. So Q of X is equal to, the first term is always 1 less than the degree. So it's x squared minus 4x, then plus 8, with a remainder of -27. So isn't that a little bit faster? I mean, it's about 6 times as fast with less chance of mistakes, because there is, in long division, remember we had to change the signs and add? All that changing of the sign occurs right here. When we took the original equation, set it equal to 0, that was all the changing of signs we needed. So from here, we just multiply and add, multiply, add, multiply, add. Everything's done. Let's look at number 6. (3x³ minus 3x² plus 2x minus 8 is divided by x plus 1. It's asking you to find Q and find R. Remember, this is P of X and this is little d of X. First step, take your little d of X, set it equal to 0, solve for X. That goes there. Now, our biggest exponent is x³, so its coefficient is 3. x², its coefficient is -3. The coefficient of x is 2, and the constant is -8. Always bring down the first term. Multiply -1 times 3 is -3. And add. -3 plus -3 is -6. Multiply. -1 times -6 is +6. Add the 2. 6 plus 2 is 8. -1 times 8 is -8. Add. negative 16. So remember, the last number here is our remainder. And this is our Q of X. So Q of X is equal to, since X, it's an X cubed, that means our first number, 3, has X squared. Minus 6 is an X, and plus 8. That's my Q of X. Ta-da! Now, will it always be so simple? Yes. Question number 7. Take our little d, set it equal to 0, equals a fraction. So x to the 4th is 3, the coefficient. X cubed is 0. X squared is 4. X, there is none. And then your constant. So bring down your first term. Multiply and add. 1/3 times 3. 1/3 times 3 is, now 1/3 times 3 over 1. The 3's cancel, equals 1. Add. 0 plus 1 is 1. 1/3 times 1 is 1/3. Now add. So we have 4 over 1 plus 1/3. We need to have a common denominator. If you could do, or you could do the butterfly method if you want. 1 times 1 is 1. 4 times 3 is 12. Add those two, we get 13. That's the top number. Multiply the bottom. 1 times 3 is 3. So we have that. So 4 plus 1/3 using the butterfly method is 13 over 3. Multiply this now. 13 over 3 times 1/3. Nothing cancels. Multiply straight across. 13 times 1. 3 times 3 is 9. So it's 13 over 9. Add. And multiply. 1/3 times 13 over 9. Nothing cancels. 1 times 13 is 13. 3 times 9 is 27. We got 13 over 27. And add. -1 plus 13 over 27. This is 1 over 1. 13 times 1 is 13. 27 times -1 is -27. So it's -27 minus 13 is 14. 1 times 27. And there's your remainder. I hope I didn't go too fast. Because imagine doing this using long division,
Yeah, so
where you have a lot. Imagine all this. Yeah. So synthetic division is the process of choice, but it only works if your leading coefficient of your denominator has no coefficient or no exponent. All right. All right, let's look at this one here. Here's my P of X, my D of X. Another way I could have done this, I could have asked, instead of having this, I could have said, what if my polynomial had -1 inside there? So if I give it to you in the equation form, you have to work it out. But if I give it to you in a function form, that's automatically your D. So if I give it to you in function form, whatever's inside the parentheses is already your D. You don't have to change the sign or anything. It's already done for you. Why would I bring that up? Let's look at number 8. We have f of x equals x cubed minus 12x squared plus 47x minus 60. Find f of 3, f of -4, and f of 5 using synthetic division. So using synthetic division. So looking at the first one. Here's my D. Now I just put it there. Here's my x cubed is coefficients 1. X squared, it's -12. X is 47. And the constant is -60. The rest of it is from there, the same. So if I give it to you inside the function, it's already given, the D is already given to you. Bring down your first term, multiply, and add. -12 plus 3 is -12 minus 3 is 9. 3 times -9 is -27. 47 minus 27 is 20. 3 times 20 is 60. And add, the answer is 0. So your remainder is 0. Your Q of X, remember, since it was x cubed, it starts off with x squared minus 9x plus 20. Let's do the next one. F of -4. So at -4, again, we use the same polynomial. So it's 1, -12, 47, -60. Bring down the first term. -1 times -4 times 1 is -4. add. 12 plus 4 is negative 16. Negative and negative is a positive. 4 times 16 is 64. Add 64 plus 47 is 111. 111 times negative 4 is negative 444. Now add. Negative 504. This is your remainder. So your Q of X, the first term is 1 less than the degree, so it's X squared minus 16 plus 111. And the last one, f of 5. We put the same numbers inside the synthetic division. Bring down the first term. Now multiply. 5 times 1 is 5. Add. Since 12 is bigger, it's negative. 12 minus 5 is 7. 5 times negative 7 is negative 35. Add. It's going to be positive. The answer is 12. 5 times 12 is 60. Add, remainder is 0. So my Q of X is X squared minus 7X plus 12. So far, so good. Now, that's the way you use, if you're given a function with some d inside there, just use that. Now, the third method is by substitution. This is a perfect leadway for it. If I gave you this, f of 3 equals x cubed minus 12x squared plus 47x minus 60. If I gave you that, what would you do? What would be your natural instinct to do? Just plug in 3 wherever x is. So 3 cubed is 27. 12 times 9. 12 times 9 is 108. 47 times 3 is 141. 27 minus 108. It's going to be negative. So 108 minus 27 is 81. $141 minus 81 the zero remainder theorem. If I have a function. Remember, it's supposed to be f of x, but whenever we have a d of x, let's say it's x plus 2, the first thing we do is set it equal to 0. So this, if I plug it in there and it equals 0, then x plus 2 is a factor. That's the fastest of all of them. Just plug it in there, see if it works.
So our real d of x then is x minus 3.
Yeah, in our example here, yeah, it was x minus 3. That's d of x. And we solved for x, we got x equals 3. So that's what we plug in there. You want to do another one, or is everybody okay? Let's do one more. Okay, I don't need much room. Let's do number 9. F of x equals x to the 4th minus x cubed minus 19x plus 45x minus 36. Find f of negative 3. It says use synthetic division, but I mean, if you want to, you can, or you can use a shortcut method I just showed you. Or you want to do both ways. With a calculator, let's go ahead and try it both ways. So negative 3 is my d. X to the 4th is 1. X cubed is negative 1. X squared is negative 19. X is 45. And my constant is negative 36. Bring down the first term. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Now multiply. Negative is a positive. 3 times 4 is 12. 19 is bigger than 12. 19 minus 12 is 7. Negative times negative is a positive. 3 times 7 is 21. And then negative 3 times 66 is negative 198. And if we add them together, we get negative 234. So there's my remainder. And my q of x, since it's x to the 4th, this one starts off with x cubed minus 4x squared minus 7x plus 66. Now, the best way to check to see if your answer is correct, just plug in negative 3 everywhere you see an x. Just plug in negative. And you can use a calculator here. What do you think the answer should come up to be? Yeah, so this method here should always end up with what your remainder is. It only gives you, yeah, it only gives you remainder. That's why this is a faster way. If it's a 0, then you know it's going to be a factor. If it's not a 0, then this will tell you what the remainder is going to be. That's your R of X. Okay, so again, you can use the calculator here and just type it in there. And if these numbers come out to be different, one of those ways is wrong. So they have to be equal. If not, then you did something wrong, check it over. But if they're the same number, then you need it right. It's either going to be true or false. Number 10. H of X equals X to the 4th plus 2X cubed plus 2X squared minus 4X minus 1. It's asking, is -2 is 1, are they zeros? Remember, what is it when I say 0, what am I looking for? It's going to be your x-intercept, your solution. Those are all the same thing. So when you hear, is this a 0? In other words, is it an x-intercept? Is it a solution? Will it make it equal 0? You can use synthetic division if you want.
It's just a substitution.
Or you can use substitution. Yeah, I'm not going to be picky which way you use, but the reason you, if h of that equals 0, then do synthetic division. Can anybody guess why?
Well, because we need the factors.
Yes, it will tell you.
This is just a quick way to see if it's going to work.
Right. So let me see, which one do we have that became a 0 for sure? Well, let's see. Let's just do these. Let's try h of -2. So we have -2 to the 4th plus -2 to the 3rd, 2 times -2 squared, 4 times -2 minus 1. This is positive 16. -2 cubed is -8 times 2 is -16. 2 times 4. Negative is a positive 8 minus 1. 16's cancel. 8 plus 8 is 16 minus 1 is 15. How about h of 1? 1 plus 2 plus 2 minus 4 minus 1. 4, 5 minus 5 equals 0. So 1 is a 0. Because h of 1 is equal to 0. So what does that tell us?
To do the one synthetic.
Yes, since x equals 1 is a solution, we know that x minus 1 is a factor. Since x equals 1, subtract 1 from both sides. It has to be set equal 0, so we know x minus 1 is a factor. All right, so let's do synthetic division. 1, 2, 2, -4, -1. Here's my h. I just went ahead and put those down here. 1 times 1 is 1. Add them, I get 3. 1 times 3 is 3. Add them, I get 5. 1 times 5 is 5. Add them, I get 1. 1 times 1 is 1. Add them, I get 0, which is what I was hoping for. Here's the beautiful thing about the remainder theorem. If you get a 0 as a remainder, we already know that x minus 1 is a factor. That's one of our factors. We only have to work with this now. Our new equation that we have to work with is x first was x to the third. So our new equation just got smaller because we took away one of the factors. We repeat the process. We're going to actually, unfortunately, we're out of time now. What we're going to do next time is I'm going to show you how to find all the possible x's that can make this equal to 0. It's called the rational zeros. Okay. What's a rational zero? What's a rational number? It's a fraction, yeah. So every number is irrational. 3 is 3 over 1. The leading coefficient we'll call P, and the constant we'll call Q. What we're going to do here is, because they are infinite number of combinations we could put in here, we have to narrow it down. We narrow it down by looking at only the first and last numbers. We take the leading number, 1, factor it out. What are all the possibilities that can fit in there? Is just 1, can't break any further. How about the last number, 1? We set it up this way. All possible combinations of this rational equation all possible combinations of P and Q have now limited the amount of answers we can have. Now limit our possible answers.
About finding all the zeros. So yeah, I think this must be the
this is, and because once we find all the zeros, we just use synthetic division and see which ones give us a zero, and then that's our answer. Because yeah, now we're building up to it, and this is probably the hardest part of the course. So, for example, I'm going to end up with one more example, and then what I'm talking about here. What if I gave you a polynomial that looks like this? What's my P of X? Is 6. What's my Q of X? 15. Well, yeah, because I'll show you why in a second, because the formula itself is a plus or minus. We'll take a plus or minus of everything. So, okay, now factor this out. What makes up 6? 1 times 6 and 2 times 3. So 1, 2, 3, 6 are all my possible values of P. What can Q factor out into? 1 times 15, 3 times 5. That's it. Right, because now what we have to do here, we have to take all the possible combinations, the plus or minus of all these, since we don't know which one's which. So we start with the top number being 1. 1 over 1, plus or minus. 1 of the Q over 2, plus or minus. 1 over 3, and plus or minus 1 over 6. Now I start with a 3. Plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 3, 3 over 6. So that takes care of the 3. Plus or minus, now I'll put 5 on top of these. 5 over 1, 5 over 2, 5 over 3, 5 over 6. 15 over 1, 15 over 2, 15 over 3, and 15 over, remember, I put plus or minus in front of all these. It looks like a lot, but some of these may be duplicates. Let's see. 15 divided by 3 is what? Is 5. Well, we have 5 over 1 is 5. So that's a duplicate of this one. 3 over 6. That's the same thing as 1 over 2. Well, we have 1 over 2, so that's a duplicate. 3 over 3 is 1. We have 1, so that's a duplicate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 26 possible zeros. Because we have 13 numbers and they're plus or minus each. So 13 pairs times 2 because of the plus or minus equals 26 possible answers. We've now taken an infinite number of possibilities and broke it down to 26 possibilities. Now we plug in each one. Now we plug in each one. Let me see. I'll pick one that I know is going to work. Here. Let's pick -3/2. So we'll put -3/2, 6 minus 1 minus 15. Bring down the first one, multiply. -3/2 times 6/1. The 2 and the 6 cancel, so we get -9. And add -1, -9 is -10. Multiply. -3/2 times -10. The negatives cancel. The 2 and the 10 cancel. 3 times 5 is 15. Well, yeah, we just now the last part's going to be 6x minus 10. Since that's a linear equation, set it equal to 0. We know for sure that this is an answer. And what's our second answer? (5/3). But are those our factors? No, those are the zeros. These are zeros. If we plug them into our equation, we get 0 as an answer. Our factors multiply both sides by 2. And add 3. So 2x plus 3 equals 0. This is one of my factors.
So you started with x equals -3/2.
Right. And whatever's on the bottom is my coefficient. So in this one, what's my coefficient? Whatever's on the bottom is the coefficient. So it's 3x. And the top is the opposite sign, -5. That's the other factor. The bottom number becomes my coefficient and the opposite sign of the numerator. So those are my factors. In other words, this entire equation here, I could factor it out into 2x plus 3 and 3x minus 5. Those are the factors. Well, see, we know we only have 2 answers. Once we find one of them, whatever's left will be the answer. If we had 3 answers, we've now broken it down from a cubic function down to a quadratic. We can use quadratic formula. You just narrow it down until you can use something much easier and then you're done. But we'll pick up from here next time. Yeah, this is pretty much how hard it gets. A lot of principle, exactly. But you notice how synthetic division is 10 times faster than long division and less chance of mistakes. And even above that, you can use the substitution method. Just plug in your d into the equation. If it equals 0, you're done. So it'll save you time what you have to do, what you don't have to do. Calculators save you a lot of time.
Just reduces the bits of pushing.
Yes.
Still a lot of bits.
Yes, there are a lot of steps. But next time I'm going to show you what's called Pascal's triangle, which tells us how many positive, how many negative answers we can have. All right, everybody, have a great day. Do your best. I hope you all had a great Easter. And if you get stuck, please send me a message. Okie doke. Y'all have a good time. Bye, everybody.